So this is question number 97. It states that theta is equal to 11 pi over 6. So we need to convert this polar form into the rectangular form, right? Looking at this, the first thing I would do is I know that tangent is an important trigonometric function here, right? Because it brings in those variables of y and x. So we can say that tangent of 11 pi over 6 is equal to uh, y over x, because we know that our theta here, or our angle here, is 11 pi over 6, while then tangent of that angle, tangent of 11 pi over 6, is equal to this ratio of y over x, right, or the opposite divided by the adjacent side. So we know that this is what we have here. Now, looking at tangent of 11 pi over 6, well, we know that tangent of pi over 6 is 1 over root 3, or root 3 divided by 3, right? That is what tangent of pi over 6 is equal to, so because that's the reference angle. However, 11 pi over 6 is in the fourth quadrant, where only cosine is positive, right? Tangent of 11 pi over 6 therefore must be negative. So we're saying that y is equal to, obviously this is negative root 3 over 3, right? And we're multiplying this by the x. And if you look at this, this is really just the equation of a line, right, where this is your slope, right? It's in the form of y is equal to mx plus b. You don't have an intercept, so that means this line is passing through the origin, right, 0, 0. The slope is negative root 3 over 3. But this is an interesting thing, as we know that if you have something like r is equal to 4 times sine theta, or 5 times cosine theta, that gives you the equation of a circle. Similarly, if you're given the polar form of theta is equal to a specific angle, when you convert that into the rectangular form, you will always be getting the equation of a line. So that's another thing you want to keep in mind. You know that theta is equal to an angle, you do tangent of that theta and you move the x, and so you see that you get the equation of a line. And that makes sense, because on the circle, or whatever circle you have, if you're referring to a specific point, so here 11 pi over 6, right? So 11 pi over 6, you know, for instance, so if I do convert this, so I know this is 130, right? So 30 times, so 330 degrees is what we're looking at. So 330 is obviously in quadrant 4, right, somewhere here, and clearly we know that that's the point that we're looking at, and this shape over here is a line, right? I mean, there's no doubt that this is a line, especially with a negative slope. As x increases, y will decrease. So this is your equation, right, with a negative slope. So that's question number 97, and that really is the end of our review here. I do have one more problem that I just want to go over for the sake of it. So it's just question number 98. You can, or it's just one extra problem that I have. So it is r is equal to 1 divided by 1 minus cosine theta, and we want to solve this, right? So looking at this, we know that we can move this, so we can multiply both sides by 1 minus cosine theta, so that gives us r minus r cosine theta is equal to 1, right? And so now we have r cosine theta, right? Because my goal is to bring this into the rectangular form. If I have r cosine theta, that is really just referring to x. So this becomes r minus x is equal to 1, right? Now if you think about this, you know, you could square this thing, and then but then you would just be left with r x's, and then, you know, you can say x is equal to r, and it would just become more confusing, right? Our goal is to get all x's and y's. So we have one x here, but we still have this r. So what I would do is I want to isolate the r, right? So I would say that r is equal to x plus 1. And now I can get r squared. We know that r squared is equal to x squared plus y squared. So if I say r squared, we know that r squared is equal to the square of x plus 1, right? And so r squared is obviously x squared plus y squared, right? That is equal to, so you can solve this. So this is x squared plus 2x plus 1, right? And so you can further, now you have everything in terms of x's and y's, and that's a good thing, because by squaring r, we were able to get x squared plus y squared, and we know that this is really just x squared plus 2x plus 1. Now we can further solve this. We have y squared, right, and then we want to, obviously the x squares go away, and we can subtract 2x from both sides, so we get y squared minus 2x, and then we have minus 1 is equal to 0. right? Again, it's just better to set your equation equal to 0, especially if you do not know which conic it is really representing, right? It could be a circle, parabola, hyperbola, or an ellipse, but if you're not sure, just set it to 0. If you're sure, then yes, obviously do bring it into that form that you know, right? That standard or general form. So here we have y squared minus 2x minus 1 is equal to 0. So that is our answer to question number 98. So yes, this has been a good review here. I did go over trigonometric functions, their graphing, sequences, arithmetic, geometric, limits, rational functions, polynomials, and as well as various concepts in geometry and algebra. So I think if you complete this review and truly understand the fundamentals that are being applied here for pre-calculus, you will be ready for calculus. So thanks for going over the review. So thanks for your time.